Here we have question 12, page 388. We're given that x is equal to 5 cos theta, y is equal to 4 sine theta, and we find that the equation of the tangent at the point 5 cos alpha, 4 sine theta, is 5y sine alpha plus 4x cos alpha equals 20. Now, as we're going to need to find the area of the parallelogram, it's worth just working out what it is, and it's easy because this is the line y equals 0. If y is equal to 0, then x is going to be equal to 5 over cos alpha, and that's the base of that triangle there. And this one, the height here is going to be 4 over sine alpha. So we're going to need 4 of those triangles. 4 times a half times the base, 5 over cos alpha, times the height, which is 4 over sine alpha, and that altogether gives you 80 over 2 sine alpha cos alpha, which is sine 2 alpha. So there's the area of the parallelogram. It's going to be useful later on. Now, to find the area of the ellipse, once again we're going to work with a quarter, and it's going to turn out to be a negative consequence to the integral, but we're going to neglect that because areas can only be positive, as we'll see. So first of all, we're going to go for page 317, where we get the formula for the area under a curve when we're working parametrically, and it's given as a is equal to the integral of y dx by dt dt from t1 to t2. And next thing, we have to turn that into one which is suitable for our own purpose, so the integral from theta 1, which is going to be 0, to theta 2, which is going to be pi over 2 of y dx by d theta. Now we may substitute, and we're going to get in the end 4 times the integral from 0 to pi over 2 of y, which is 4 sine theta, times dx by d theta, which is minus 5 sine theta, and there we can see that negative turning up, which we're going to be ignoring. Now you should be able to integrate sine squared theta d theta from 0 to pi over 2, starting with the formula cos squared theta minus sine squared theta is equal to cos 2 theta, and that should enable you to work out something that's easy to integrate here in place of this one. Well, that's going to give you 20 pi. So the difference between these two, 20 pi and 80 over sine 2 alpha, will be the area enclosed between the ellipse and the parallelogram. So it will be this area 4 times. So this is the area. It's going to be 80 over 2 alpha, sorry, sine 2 alpha minus 20 pi. And that's the area between the ellipse and parallelogram. Now, if the area between the ellipse and the parallelogram is equal to the area of the ellipse, we're going to find for part D that we have this situation here, 80 over sine 2 alpha minus 20 pi is going to equal the area of the ellipse, which is 20 pi again. Better write that in there. Area of ellipse, the result of our integration. Now that's an equation one should be able to solve quite simply by oneself.